Hello everybody and welcome to another enVision's Algebra 2 video for topic 3, lesson 7. We're going to look at example 3, graph transformations of a cubic and quartic parent function. So quartic meaning x to the power of 4. We've seen transformations of absolute values and quadratics in topic 1. So this is taking it a step further. All right, so how does a transformed graph compare to the graph of the parent function? Well, let's start with the parent function f of x. Let's talk about transformations. So if I have the parent function f of x and I want to make a vertical translation or shift it up or down x units, I do f of x plus k, where plus will move it up, minus will move it down. So this is vertical shift. Okay, where f of x again is my parent function. If I wanted to do a vertical scaling, that means pull it vertically like a rubber band. If you're pulling a rubber band to the sky and down to the ground, that's a vertical pull or a vertical scale. That one would be a times your parent function f of x. I don't know why I said times very loud. This is a vertical scale, which means the scale means that you are compressing or you are stretching that graph, like you would compress or stretch a rubber band. All right, let's say I want to look at the horizontals. Let's say I want to shift it horizontally, left or right. What that would look like is f of x minus, the minus is part of the equation. Let me choose, that's blue, h. Ooh. And this is a horizontal shift. And remember, if this is a negative h, you want to instinctively go left, but the negative is part of the equation, so we're just looking at this h, so that's going to make you go right. But like I said, horizontals lie to you, so if instinctively you want to go left, go right. If this is a positive that makes you want to go right, you're really going to go left on the graph. All right, and let's say that we have a horizontal scale. This is going to look like f of b. I'm going to use purple for this, b times x. And the whole reason I put the x in the parentheses is because what you really want in a horizontal is that b to be on the outside. So if I had something like this, I want to be able to just distribute the b. So that means if the b is already distributed, if you have something like f of bx minus bh, you want to pull that b out. You want it to be in the front. You want it to be foiled or factored out. Not foiled. That's foiling your plans. All right, or factored out. Erase all that. So this is going to be a horizontal scale. And that's, again, you're taking that rubber band along the horizontal, along the left and right. You're either squishing it or you are stretching it. So compressing it or stretching it from left to right. All right, again, if this is b, you're going to be a horizontal scale of a factor of 1 over b. This is right, h. This is by a factor of a, and this is up k units. All right, so looking at this, a parent function for a quartic, would be x to the 4th. So if I were to manipulate x to the 4th, let's say I do x minus h to the 4th. This would be my horizontal. So this might be x plus 3, x minus 2, but this would be a horizontal. Okay, if I did 3x to the fourth. This is vertical. I should probably kept the colors I had above. If I did x to the fourth plus k, I should have kept this a as well. Let me put this as an a. Then this is going to be vertical shift. And then if I had a x to the fourth, this would be horizontal. So let's look at our function here. Our function is 3x to the fourth minus 18. Okay, so already I can see that I have an a times x to the fourth. So this a is equal to 3. K is equal to negative 18. Okay, so there you go. This is the a that I'm talking about. This is the k. So we're looking at both verticals. This is a vertical stretch by 3 and shift down by 18. So scale by a factor of 3. And this is a shift down. Vertical shift down 18 units. So let's look at, I'm going to assume that Savis has the graph. So let's look at the graph. So identify the transformations. So our transformations, here's our parent function. We identified our transformations as 3 and negative 18. The leading coefficient 3 stretches the graph vertically. So again, we're stretching that and making it narrower. It's like a rubber band. The rubber band is kind of wider, and then when you stretch it, it becomes thinner. So you see this thin orange graph. So it stretches it, it pulls it. So although this doesn't look like it's stretching, just picture that rubber band being stretched. And then a vertical translation down. So we're moving down 18 units. So that is right above the negative 20. So that's what the transform looked like. That's what the parent function looks like on this graph. All right, so what about this one? We have A, B's, and C's. So let me go here. Let me paste that there. Again, we have, I'm just going to use black A. We still have the cubed, but x cubed will be my function here. So this is a, b, x minus h cubed plus k. Again, still following that transformation idea of what goes inside the parentheses and what goes outside the parentheses. All right, so here we have on the outside a, which is our vertical stretch. Our compression is 5, and this, 5, which is a stretch. And you might be asking, Miss Abney, what's a compression? Anything less than 1 would be a compression. Greater than 1, it's a stretch. All right. Second thing, it looks like I have an h. My h is going to be positive 2 because, again, you do the opposite signs, which means that this is a horizontal. This is vertical. Horizontal. Shift. Right. 2 units. And then the last one is our k. K in this case equals 4, which is a vertical shift up 4 units. So what we should see is this. Let's say this is my cubic. It's an odd function. Leading coefficient is positive, so it's going to look something like this. It's going to be rotated around the origin. All right, nice XY. And what's going to happen is this is going to stretch it. So this is going to be a little bit more narrow, like that, because again, like a rubber band, we're stretching it. Then we're going to move it over by 2. So let's say this is 1, 2. So it's going to go like this, over by 2, and then down by 4. I should have used green. 1, 2, 3, 4. I'm using each one of these. So it would look something like that. I'm sure their picture is going to look a lot better than mine, so let's go look at theirs. So identify the transformations. So 5, 2, and 4. That's what we did. Horizontal translation. So they did their horizontal translation first, which you should actually do. You should move it over horizontally first. You should do all the order it should be done is horizontal scale, then translation. So horizontal scale, then shift, then vertical scale, then shift is the way it should actually be done. So let me write that down. So you do horizontals first. So horizontal scale. That's that B coefficient. And then horizontal shift. That's the H. Then vertical scale. That's the A in my equation or my expression. And then the vertical shift, which is K. So it should be BHAK. And so they follow that. B is going to be the first one, your horizontal. In this case, we don't have a B. B is 1, stays. We're going to then do the shift over 2. Then they're looking at the leading coefficient. That's the scaling. Tightens it up. And then down, or, oh, sorry, up 4. Why did I go down 4? I should have gone up 4. Don't know why I went down 4. So always double check. And that is it. So the graph of the parent function is a valuable tool because it provides a foundation for sketching the graph and related function in the transformation. See, this is why I like class, because you guys would have said, Miss Avni, why are you going down? You should go up, because this is a positive 4. And that's because Miss Avni was not paying attention to her own work. So make sure that you double check these and that you make sure you're going in the right direction. All right, so there you have it. That's example 3. And the try it is going to probably be looking at the transformation. So again, this has an A and a K. And so talk about how this is different from the x cubed. All right, we'll catch you guys in the next video.